Greetings to each and everyone. Welcome to this new video where we are going to be solving a mathematics question. That is, we are going to be solving pure mathematics with mechanics, paper 3, June 2022, question 1. Okay, the question reads: the position vector r of a particle of matter kilogram at time t seconds is given by r equals 3 sin 2t I plus 4 cos 2t j meters. We are asked to find when t is equals to power on 8 the magnitude of the momentum of the particle, b the force acting on the particle, c the power developed by the machine. So we are going to say there is into the solution of this question. So we have to note that first of all, in the a part of the question, that since we have been asked to calculate the magnitude, to find the magnitude of the momentum of the particle, actually in the first place we have first of all to determine the momentum of the particle actually. So once we have determined the momentum of the particle, we can then look for its magnitudes. Okay, actually, so that is how we are going to proceed for the a part of the question actually. So knowing that the momentum, the formula to get the momentum of the particle actually is the mass of that particle multiplied times its velocity actually. The mass of the particle is given to us to 3 in the equation, 3 kilograms, and the velocity actually we can get the velocity, okay, by simply what? By simply differentiating, okay, the position vector with respect to time actually, okay. So saying that implies the momentum actually is going to be the mass, which is 3 kilogram, times the times the derivative of the position vector with respect to time. Okay, so differentiating actually the position vector with respect to time, actually it simply means we have to differentiate this r, okay, with respect to this time, which is with respect to t here actually. Okay, so knowing that actually r is equals to 3 sin 2t I plus 4 cos 2t j meters, it implies differentiating r, okay, with respect to t, we are going to obtain 6 cos 2t I, okay, 6 cos 2t I, okay, minus 8 sin 2t j. Okay, how did we obtain it? Actually meters per second, of course, because the SI unit of the velocity is meters per second actually. How did we get actually this how did we get this result? Actually, it's very easy. What was done is that once you are going to differentiate this, okay, actually you are going to differentiate first of all 2t, okay, you're going to differentiate 2t, okay, respect to time, okay. So you are going to obtain 2, you are going to multiply that 2 times the 3, which you are going to obtain 6. And once we know that once we differentiate a sine function, we obtain cos actually, and at the end you still put back that 2t actually. So that is the process on how you have to differentiate such questions. Yes, actually. So doing the same process for cos, for 4 cos 2t, actually knowing that once you differentiate a cos function, you have minus sine, okay, actually. So that is it. So if you apply the same process, you are going to obtain this minus 8 sin 2t, negative 8 sin 2t j, and then meters per second, which is the SI unit of the velocity actually. Okay, so since we already have the velocity, we have the mass, we can therefore get the momentum directly by simply multiplying the mass, okay, times the velocity actually. So doing that, we are going to obtain the 3, which is the mass times the velocity actually, and the unit of the momentum is actually kilogram meters per second actually. Okay, but remember, we are asked to find the magnitude of the momentum of a particle, okay, when t is equals to pi on 8 actually. So once you arrive at this stage, actually you have to go and simplify. You have to go and replace everywhere you see t with pi divided by 8 actually. Okay, so doing that, actually we are going to obtain yes, you can first of all multiply the 3, okay. You can first of all multiply 3 times 6, you get 18, and multiply 3 times you can multiply 3 times negative 8, actually you get negative 24, okay, like this. Okay, yes. So replacing now everywhere with t, because we know that t actually is equals to pi divided by 8. Okay, so replacing everywhere with t with the pi divided by 8, we get the momentum actually to be equals to 18 cos 2 open bracket pi divided by 8i minus 24 sine 2 open bracket pi divided by 8, okay, j actually. So you can clearly see that simplifying this furthermore, we can clearly see that this 2 is going to cancel with this 8 actually. So here we are going to be left with pi ln 4. Okay, similarly for this side. Okay, so once you are going to simplify this, you are going to obtain cos pi ln 4, and we all know that cos pi ln 4 is square root of 2 divided by 2, and same thing for sin pi ln 4. Okay, so doing that, actually we are going to see that yes, as I told, as I said, as I explained, that once at this level you're going to obtain cos pi ln 4. Okay, and similarly here you're going to obtain sin pi ln 4. You know that cos pi ln 4 is what square root of 2 divided by 2. I know that the sine of pi ln 4 is also the square root of 2 divided by 2 actually. Okay, so these two here we cancel here. This 2 goes here once, this 2 goes here 9 times, 2 goes here 1, 2 goes here 12 times. Okay, so actually if you do that, actually you are going to obtain 9 square root of 2i. Okay, yes, minus 12 square root of 2j actually. But as the question A says that we are asked to find the magnitude or the momentum of the particle actually, so you then have to get the magnitude, of course, of this momentum actually. As I said, once you are going to simplify, once you are going to simplify this expression, you are going to get 9 square root of 2. Okay, and once you are going to simplify, you are going to obtain uh, negative negative 12 square root of 2. Okay, so getting the magnitude, which is simply what, which is simply 9 square root of 2 all that squared plus negative 12 square root of 2 all that squared, all that square root actually. Okay, we then get the momentum. Okay, we then get the magnitude of the momentum of the particle actually. Okay, to be simply equal to 15 square root of 2 kilogram meters per second. Always include the unit, very important. Okay, yes, so actually uh we are over with the A part of the question. Let us now move to the B part of the question, where we are asked to find the force acting on the particle. Yes, actually the B part of the question is still the same stuff actually, but here you have to know some basic formulas, of course. Okay, so knowing already the formula for the force, which is equals to the mass times the acceleration, actually you can easily get that force which is being asked into the B part of the question actually. So I'm saying that the force is equal to the mass times the acceleration. Okay, but in this case, actually the acceleration, we are simply going to differentiate actually the velocity which we obtain here with respect to time. Okay, so it is just the same process, okay, of differentiating. We can it's just a matter of differentiating the velocity in order for us to get the acceleration actually, because the mass already given to be 3 kilogram actually. So we only need here, the only thing that we need here is the acceleration, which is actually what, which is actually dv dt actually. Okay, so saying that implies the force actually is going to be the mass times dv dt actually. Okay, knowing that v actually is equals to what, knowing that v is equals to 6 cos 2 ti minus 8 sin 2 tj meters per second, that is the velocity. Okay, knowing that the velocity, this is the velocity actually that we proved here by simply differentiating the position vector, we are then also going to differentiate the velocity, okay, with respect to time in order for us to get the acceleration actually. Okay, yes, so saying that implies that we are going to have what, we are going to have the v dt to be equals to negative, okay, to be negative 12 sine 2 ti, okay, minus 16 cos 2 tj meters per second squared. Always remember to input to put the SI unit, because it is very important actually. Okay, so actually to differentiate this is quite the same process as we did for when we are differentiating the position vector actually with respect to time. Okay, yes, so actually once we differentiate the velocity, okay, with respect to time, actually we get this actually. Okay, so Now since we already have the v, the t, okay, we already have the mass actually. Yes, actually these two parameters is already enough for us to answer the v part of the question, that is the force actually, having in mind that t is equals to pi divided by 8. Okay, yes, it implies actually the force will be therefore be equals to the mass, which is 3 kilogram, okay, times negative times negative 12 sine 2t 2ti minus 16 cos 2t j meters per second. Meters per, excuse me, here we are supposed to have meters per second, meters per second squared. Yes, excuse me, yes, it's meters per second squared here, because this is actually the acceleration, okay, and this one is the mass actually. Okay, yes. So proceeding, that is multiplying, knowing that t actually is equals to pi divided by 6, pi divided by 8, excuse me. Actually we are going to get what we are going to get, the mass, which is 3 kilogram, times negative 12 sine 2, everywhere we see t we replace with pi divided by 8, and similarly we are going to have minus 16 cos 2 open bracket pi on 8 actually. Okay, so yes, actually yes, we are going to have that. Okay, excuse me, yeah, I think I wrote it twice, there's no problem about that. So we are simply going to identify that here actually we are still going to have sine pi on 4. Okay, similarly here we are going to have also cos pi on 4 actually. So the same stuff, that is square root of 2 divided by 2 at this level here, and similarly here we are going to have the square root of 2 divided by 2 actually. Okay, yes. So as I said, yes, we are going to have the square root of 2 divided by 2, that is, you are going to have the mass, which is 3 kilogram, times negative 12, okay, times this open bracket square root of 2 divided by 2i minus 16 square root of 2 divided by 2j meters per second squared. Okay, because here you have kilogram, here you have meters per second squared. So remember that here this actually is the SI unit of the acceleration, which is this. Okay, actually this is the acceleration and this is the mass with its SI unit. Okay, yes. So doing this, it simply implies that we can do some simplifications here actually. So 2 goes here one time, 2 goes here how many times? 2 goes here 6 times, and if we do now the 3 times negative 6, we are going to get negative 18, and similarly here negative 18 square root of 2 actually, and here similarly once you cancel out these 2 and here and the 16 here, we are going to get 8, and 3 times negative 8, we are going to get negative 24 actually. So it implies therefore that our force is going to be negative 18 square root of 2i, okay, minus 24 square root of 2j Newton. Okay, actually, so the C part of the equation, we are being asked to calculate the power. We know that the power actually is equal to the force times the velocity actually. Okay, we already know the force, which we calculated already here, but we are going to go gradually. In fact, so we are going to take the expression of the force at this level, okay, before replacing the value of t inside. Okay, that is, we are going to obtain the force to be we are going to obtain the force actually to be equals to negative 36 sine 2t. That is, we have multiplied this 3 times this negative 12 actually to get negative 36. Okay, similarly we have multiplied this 3 times this negative 16 to get now this negative 4, this minus 48. Yes, you can say it like that actually. And the dot product, remember here you have to take note that here we are working with dot product. Okay, yes, so you are going to see at the level at which you are going to lay more emphasis on that. Okay, so actually the velocity actually is still the same velocity that we are going to take here, that is when we have differentiated the position vector actually. Okay, yes, and the SI unit of power is actually the watt. Okay, yes, so actually here, but we know that t is equals to pi divided by 8. Okay, so replacing it actually into this expression of the power, we get this expression. Okay, that is everywhere we saw t will replace 8 with pi on 8, everywhere we saw t will replace pi on 8, similarly for this and for this also. So you are going to come back to the same stuff here actually. Sine, we are going to have sine pi on 4 here, you're going to get cos pi on 4 here actually. Okay, similarly you are going to have cos pi on 4, and similarly you are going to have sine pi on 4 actually. So doing that implies that we are going to have this expression actually. So since here we are going to have the square root of 2 divided by 2, Actually, it means the two which is going to be down is going to cancel this 26. So we're going to the 2 which is going to be just in the denominator. Actually, it's going to go one time here, and here you're going to go negative 18 times. Okay, reason why negative 18 times, that's the reason why we have this expression here. Okay, similarly, you are going to have the square root of 2 divided by 2 here. The 2 goes here one time, and the 2 goes into 48 24 times. Okay, similarly here, the 2 which is under row, we cancel 6 to be left with 3, and the 2 which is going to be down here, that's the 2 which is going to be under square, the 2 which is going to be in the denominator is cancel 8 to have 4 here actually. Okay, so dot product simply means that we are going to multiply the corresponding entries together. Okay, so you are going to multiply the I components together. Okay, that is, you are going to multiply negative 18 square root of 2 times 3 square root of 2. Okay, and similarly we are going to multiply the J components together, that is negative 24 square root of 2 times 4 square root of 2 actually. Okay, yes, so doing that we are going to obtain the value of p to be negative, okay, to be negative 108 plus 192 actually. Okay, yes, which actually implies that the value of p actually, which were the value of the power, which is p in this case, divided by the machine, will actually be equals to 84 watt. Okay, thank you very much for watching this video, and remain tuned for a very interesting mathematics question. Thank you.